A 20 kg solid disc pulley is attached to a hanging 10 kg block which is released from rest 500 meters above the ground. How fast will the block be moving before it hits the ground? So, moment of inertia of the solid disc is 1 over 2 mr squared. Now here we have got first the pulley. Let's name it as capital M. And then we have got this mass which is falling. Let's name it M. Now this mass initially is at rest. We can use either the conservation of energy or torques to analyze this question. Starting with the conservation of energy, the mass is really at rest, so it has got potential energy because it is able to fall. And that is going to be converted when it starts to move. When it is released, it starts to move. It's going to be converted, it's going to have kinetic energy. So converted to kinetic energy. And also this thing will start rotating. Why? Because it is connected by the cord, and in the cord there is a tension force there. Because of that, this thing will start to rotate, so there will also be rotation kinetic energy. Now the potential energy is given by mass, and this is small mass gh, and then kinetic energy, this is half small mass and then v squared. The kinetic energy of rotation, this thing is going to be given by half. The equivalent for mass in rotation terms is inertia, moment of inertia. Velocity, that will be the angular velocity squared. So this will be mgh is equal to 1 over 2 mv squared plus 1 over 2 moment of inertia. Now the moment of inertia has been given as 1 over 2 again, multiplied by mass. Now here is the mass of this system because the one which is rotating, so capital M, and then multiplied by radius squared. Angular velocity is given by linear velocity divided by the radius. If we square this, we are going to square also these two. So this will be v squared over r squared. So this will give us mgh being equal to half mv squared plus, if we multiply this, that will give us 1 over 4, and then capital M. The r squared and the r squared cancels, that will be v squared. Now we'll go on substituting. The small mass of the dropping mass is 10, g is 9.8, the height is asked to drop for 500 meters, should be equal to half the mass. The small mass still is 10 kg. We don't know the velocity at which it will be dropping, plus 1 over 4 the mass of the pulley, that is the solid disc, that is 20, and then v squared. Well, if we do the multiplication, 10 times 9.8 times 500, that should give us 49,000. And 2 can go into 10 5 times. 4 can go into 20 5 times. 5, this is the 49,000 I said. Okay. 5 plus 5, that is a 10. And 10 into the number which you are, so this will be 49,000 is equal to 10 v squared. So the 0 here cancels out with the 0 here. This will be v squared is equal to 4900. Now to remain with you, are going to square root, and that is going to give us 70 meters per second. That is one way which we can use. Now using torques, we are going to talk about the net forces acting on the mass which we have, the mass which is dropping. Now because it is moving down, we are going to take motion down as positive. In other words, acceleration down, we are going to take it as positive. So positive acceleration is down. So the net force acting on this object in the y is given by what is putting it down is the weight of this same object, that is mg. But there is also what is putting it in the opposite direction, which is the tension. And the net force is supposed to be mass times acceleration, and that is going to be mg minus tension. Now this same tension which is in the cord is causing rotation to the disc, because we know that when we have got, this is a disc, there's a radius here, and then there's a tension here. tension, and then there is the radius. Anything that makes 90 degrees like this, if we multiply this with this, that is going to give us the torque. So the torque here in this case is equal to the tension multiplied by the radius. Now the torque, the tension is therefore going to be equal to torque divided by the radius. So where there is tension, I'm going to put torque over radius. And this is going to be MA is equal to mg minus, but torque, we also know from Newton's second law of motion that force is given by mass times acceleration. The equivalent for torque in rotation terms is, the equivalent for force in rotation terms is torque, and mass is inertia, acceleration is angular acceleration. So where there is torque, I'm going to put inertia times angular acceleration divided by the radius. So this will be mass times acceleration is equal to mass times gravity minus, where there is inertia, we're going to substitute now half. But when we're talking about inertia of something that is rotating, and the one which is rotating here is the solid disk, so it is capital M, and then radius squared. Where there is alpha, angular acceleration is linear acceleration divided by the radius. So I'm going to substitute linear acceleration over radius, but there is also another radius in the denominator there, so this will just be radius squared. And from here we'll see that MA is going to be equal to mg minus 1 over 2m. The r, of course, will cancel out with the r here, and then there will be a here. So the small mass we are going to substitute, this is 10 times acceleration. Small mass is still 10 times g, which is 9.8, and minus half. The big mass there is 20, the mass of the disk, times acceleration. So this is 10a is equal to 98 minus half times 20, that is a 10a. Taking the 10a the other side, that will be 20a, and that is going to be equal to 98. That means the acceleration of the system is going to be 98 over 20, which is 4.9 meters per second squared. Now we want how fast is it moving. We want the velocity at which it will be moving before just hitting the ground. Can use any equation of motion. We know that final velocity squared is equal to initial velocity squared plus 2as. Now the final velocity is what we are looking for. The initial velocity, we have been told it is released from rest, so that is 0, and then plus 2. This object is accelerating as 4.9. I would have used g, but this is not free fall. That is why I've used acceleration. And then the distance that it has to cover, that is 500. So this will give us v squared being equal to 4.9 multiplied by 2 multiplied by 500, that is 4,900. To remain with v, we are going to square root that value, and that is going to be 70 meters per second, as we found with the previous formula. So that is going to be it for this one. Let's look at just one more problem to make sure that we've understood. A system of a 0.2 meter radius pulley having two masses tied on a rope is released from rest as shown. So here we are, this system. Now determine the acceleration of the system and the speed when the heavier mass falls for 20 meters. So the direction of motion is, this thing is moving like that. So considering first this object, which this system, this side, of course we have got the tension supporting mass in here. Let me call this as tension 2. We also have the tension here. Let me call it tension 1. And there's a weight force on this object. There's also weight on this object. So all those are supposed to be taken into account. But acceleration is in this direction. So we're going to take acceleration in this direction as positive. Okay, like that. So let's consider the net forces which are acting on this object. What will be the net forces which are acting on this object? Okay. So net force, we are first going to consider motion here, and also are going to look at motion on this one, because we have got two masses. This mass is going up, this mass is going down. So let's look at the mass which is going down. So the net force, that is net force into, is going to be equal to, what is causing it to go down is its weight. So that is the direction of motion, m2g. So I'm going to call this as m2 because we have got tension 2 there. And then minus the force going in the opposite direction, that is t2. Of course the tension is going to be, okay, that is going to be t2. Now this thing is accelerating going down, and the net force is going to be equal to mass times acceleration. So that will be m2 times acceleration, and that will be equal to m2g minus t2. So let me make t the subject, the formula here. I'm going to take t the other side, and then I'm going to bring this term the other side. So that is going to give us t2 being equal to m2g minus m2a. So we're going to keep this equation here. Now let's also work at this. Now for this one, it is accelerating going downwards, because if this one is going down, this one is going to be going up. So the acceleration is positive going up. So therefore the net force on y, on 1, is going to be equal to the force pulling it up is T1. What is going in the opposite direction, that is its weight, that is m1g. And the net force is m1 times acceleration, that is going to be T1 minus m1g. So I'll take this term the other side to remain with T1. Therefore T1 is going to be equal to m1a. If this one goes the other side, becomes positive, so plus m1g. So these are going to be the two equations. Now again, by reason of the movement of the rope, when the rope gets to move downwards, it's going to be causing a rotation in here. Okay, there will be a rotation. So because of that rotation, there will be a torque which is going to be caused. So now, how do we get to find torque? We know that torque from Newton's second law, torque is equal to moment of inertia times the angular acceleration. Now this torque is going to result because of the movement of this thing like that. So there is a tension. This tension too is pulling this thing down like that, and then this side is going up. So the difference in the torques this side and this side, that is what is going to cause the net torque in the system which we have. So what are we really saying? So if you have got this object like that, this thing is pulling down, and then there is one which is moving on top like that. So the difference in those torques is what is going to cause the net torque, which is going to make this thing to start moving. So what we are saying is, where there is torque, we are going to put the torque which is in this rope, the rope on this side, and the torque this side. So that the torque first this direction where it is going down, that is going to be, how do we find torque? So since we have got tension 2 here, I'm going to also call the torque that side as torque 2 minus torque 1. This should be equal to I times the angular acceleration. So now torque, how do we find torque? Torque is given by force times radius. So this is going to be force 2 times radius, and then minus torque 1 will be force 1 times radius, and this should be equal to the moment of inertia. Well, even here we have got the same situation like the previous one. The moment of inertia of this solid disk is 1 over 2 mr squared. Now this m we are going to use here is let me give it capital M, and let me give this one no, m1, small m1. This will be small m2. Okay, like that. So the torque will be capital M, half, we are substituting on moment of inertia, that is half m and then r squared. And then we have got angular speed, which is just linear speed divided by the radius like that. Okay. So from here, what are we getting? So this is going to give us, we're going to factorize out r because it's common. That is going to be f2 minus f1, and then this will be r. This will be equal to half capital M, and then r squared, angular acceleration over, linear acceleration over r. Now from here we can see r here will cancel with one r there. The one r which remains will cancel with this r which is here. So what we are going to have is f2 minus f1 is equal to 1 over 2 capital M. Okay, but what is f2? This F2 is simply the torque, the second tension, because F2, this F2 is being caused by the tension there. So the tension is going to be the F2 we are talking about. So we're going to substitute our tension 2, which is M2G minus M2A. And then minus, where there is F1, we're going to substitute there, which is M1A plus M1G. And this should be equal to half M. I, I even forgot to write this A which is here, so it's supposed to be there. So let's get to write that now. Well, that is going to be M2G minus M2A minus M1A minus M1G is equal to half capital M and then A. I'm going to take everything with A to one side. So we are going to take them this side. So first we have got half capital M and then A. I'm going to take this mass the other side, it becomes positive M2A. This also the other side becomes also positive M1A, and that is going to be equal to this side we are remaining with M2G and then minus M1G. Factorizing out mass and dividing by the terms which remain, we are going to see that acceleration is equal to M2G minus M1G divided by, here we are going to have half M, M2, M1. So that will be half M plus M2 and then plus M1. So let's go on and substitute. Of course, we can also factorize out a G here so that we just add the mass and multiply by G. So acceleration is going to be M1, first M2, the M2 is there, and the mass is 8 kg, minus M1, the M1 is 4, then we're going to multiply that by G, which is 9.8, then divide that by half the mass of the solid disk, that is 5, plus M2, which is 8, plus M1, which is 4. So let's get to calculate that. 8 minus 4, that is a 4, and 4 multiplied by 9.8, that is a 39.2. In the denominator, we've got 5 divided by 2 plus 8 plus 4, which is a 14.5. Therefore, the acceleration is going to give us 39.2 divided by 14.5. That is, okay, 2.70. Alright, so that is going to be the value for the acceleration. Have I even multiplied by, let me just do that again. We see we have not multiplied well. M2, that is 8 minus 4, which is a 4, multiplied by G, which is 9.8, that is 39.2, divided by 2.5, which is 5 over 2. Okay, that is going to be it. So it is 39.2 divided by 14.5, and that is going to give us 2.70 meters per second squared. That is going to be the acceleration. Now the other question is, and the speed when the heavier mass falls for 20 minutes, for 20 meters. How do we get to find the speed when it falls for 20 meters? We know that it was released from rest, and we know that v squared is equal to u squared plus 2as. Final velocity is equal to initial is 0 plus 2, the acceleration the same 2.70, the distance that it had to fall is 20 meters. So v is going to be the square root of 2 multiplied by 2.70 multiplied by 20. So v is going to be equal to, okay, that will give us 2 multiplied by 2.7 multiplied by 20, then square root that. The velocity is going to be 10.39 meters per second. That is how fast it will be moving.